Question 2 says that in the diagram, AD cuts BC and angle A1 is equals to angle B2. Now remember that when we have two letters like AD, it means it's a straight line. So what we're basically saying here is that this line AD is a straight line that actually cuts another straight line BC, because we also have two letters here. It cuts BC. Right, so we're having AD intersecting or cutting DC at some point here. Both those lines are straight lines. And we also have a situation that there is another line between the point A and point D, such that they create vertices here, which now, of course, the vertices will make angles here, A1 and angle A2, angle B2 and angle B1 and angle B2. And we are told that angle A1 is the same as angle B2. So that's what we have in this problem. Then the question goes to 2.1 to actually say to us that prove that angle A2 is equals to angle B2. So now we want to prove that this angle here and this angle here, they are actually the same. Now, usually to tackle this type of a problem, it is actually wise to begin your problem by writing what you are given. In other words, by writing down the fact that angle A1 and angle B2 are the same. The reason to actually do that is because this argument can be important or can play an instrumental role in solving this problem. Now, after I've written the fact that angle A1 and angle B1 are the same, I need to give a reason why I say this they are the same. Well, and the reason here is the fact that I'm given. I was told in the problem is the information that we start with in the problem. Now, following that, to be able to answer this problem, you must realize that we are requested to prove that two angles are the same. That means I should use theorems that code angles or that have angles in them. And to do that, I see that we know that this line here is a straight line. And I can see that A1 and A2, they're actually adjacent to each other. And that would mean that they are angles on a straight line. So we can conclude that they are supplementary if we add them. Now, that means I can come here and say angle A1 plus angle A2, they are actually equal to 180 degrees. And the reason for that would simply really be the fact that angles on a straight line are supplementary. Angles on a straight line are supplementary. Now, if we look at our diagram, we can also come up with angles by acknowledging the fact that we are given the line BC and I have this angle and this angle. They are next to each other, they are adjacent to each other. So it means when I add them, they must also be supplementary. That means I'm going to repeat the same theorem here for angle B. And what that will do is that I can simply write a statement here to say similarly, meaning I'm saying that if I do the same as I did here, I am able to actually say angle B1 plus angle B2, they are actually equal to 180 degrees. Now, if I use the word similarly, I don't have to write the reason, because I'm simply saying I'm doing the same thing that I did at the top here. Or if you like, you can actually remove the word similarly and actually write angle B1 plus angle B2 is equals to 180 degrees and give a reason here to say angles on a straight line are actually supplementary. It's the same thing. It's just that sometimes it is useful to do or to write the word similarly and repeat the same thing that we did above. Now, at this stage, we can then use this argument here at the top to say angle A1 is the same as angle B1. That means where I see B1, I can replace it with A1 because really they are the same, these two. Now, it means here I'm going to say I can say therefore angle A1 plus angle B2 is equals to 180 degrees. All that I've done is that I've replaced B1 with A1 since they are the same, they are equal. And I've just kept this as it is and that as it is. Now you then have to realize that these two statements, angle A1 plus angle A2 is equals to 180 degrees, and I have angle A1 plus angle B2 being equal to 180 degrees as well. So they're exactly the same. They are the same thing. They both give us 180 degrees. That means I can argue to say this implies that angle A1 plus angle A2 is equals to angle A1 plus angle B2. So what I'm saying the sum of these two angles must be the same as the sum of these two angles, because both of these two, they are actually 180 degrees. So this is 180 and this is also 180 degrees. The nice thing here, or the powerful thing, is that we are writing them in terms of the A1 and B1 instead of using that 180. Then at this stage, it should be clear to one that this angle and this angle will actually cancel each other when, I transpose them. So say, for example, I take this angle and transpose it to this side. I'm actually going to have negative angle A1, and actually they will just cancel each other, or you can just cancel them each other like that. Now the conclusion would therefore be the fact that angle A2 is equal to actually angle B2, and that is what we were requested to prove in this question.